Hi guys, back again with another video, and today we'll be talking about data science. What is the practice of data science? What goes on into data and analytics? What goes on in machine learning engineering? And yeah, basically we're going to be talking about that. So the first thing that I want to bring to your attention is the field of data science, or rather data and analytics, is quite broad. And what this means is you stand a chance to have a lot of different niche kind of jobs within the data and analytics space. Personally, I'm a specialist, strategic intelligence, and that's just a data scientist, who specializes in strategic intelligence, and I'll explain on that in another video. I don't want to talk about that today. So you see, it's also sort of like a niche, career kind of, avenue, in the data science space. And what you get to learn is there's quite a lot of these niche kind of jobs in the data science space. Now, before I delve in further, I would like us to sort of talk about the big three, as I call them, in the data science space. Number one, being a data analyst. Number two, being a data scientist. And number three, being a data engineer or machine learning engineer, depending on obviously the field where you are working, right? And from there, I will provide guidance, and I'll also provide advice as to what I think is the best kind of way to start in the field and how to take it from there, right? So, the first one, what is a data analyst? So I'm going to put things simply. I'm not going to look for some meaning from the internet and then just put it on the video. I'm just going to basically talk about what a data analyst does. So a data analyst consumes data and creates dashboards out of that data. Those dashboards will provide business with actionable insights, right? So, for example, let's say you're a data analyst working in sales. Your dashboard can obviously show things such as sales over time, losses made over the previous year, how much profit is being made in the current year, and a bit of forecasting. And that forecasting, there's an asterisk to that, because now there's an overlap between a data analyst and a data scientist, and I'm going to touch on that going forward. Now, moving on to data scientist. What is a data scientist? Now, what a data scientist does is they will use the data, right, to sort of create models that can predict the future, basically, and so a data scientist role is not necessarily about creating the dashboards. A data scientist will create the necessary models to basically forecast profits, to forecast risk, whatever, right? It depends on the business needs. And now we're moving on to your data engineer. What does your data engineer do? So what your data engineer does is basically they prepare the data for the data scientists and the data analysts. And how do they prepare this data? They build scalable pipelines, right? So they find a way, or they build solutions that will take the data from the lake, or from a server, or from an API, whatever, and then they will get that data to the data scientist. They will get that data to the data analyst. And again, what a data engineer also does is the governance around the data. So if you work in big corporations, right, you will hear this term being thrown around a lot. The governance of this, governance of that, and that talks to how you basically govern your data processes, or your processes that give you the data. Do you have the necessary data quality controls in place? Are you following best practices? For example, I'm going to put this loosely. Do you have passwords stored somewhere in a server, or somewhere where it's not, safe and doesn't follow best practices? So the governance talks to all of that. How you get the data from source to your environment, or to your production environment, right? So another thing that a data engineer does, and I feel like I'm touching a lot on data engineering at this point, Another thing that a data engineer does is they can provide the data scientists with a sandbox environment. And the importance of this is data scientists are very notorious for messing up with people's data and using all computing resources, right? It's machine learning, it's building data models, it's LLM development. So obviously data scientists would use a lot of machine resources, right? But we kind of get selfish in the sense that we just want to take everything, and it doesn't work like that. Resources need to be allocated accordingly, right? And they need to be consumed based on, a lot of factors. And basically we need to make sure that business goes on. We don't allocate all the machine resources to the data scientist. So what how data scientists normally work is they get like a sandbox environment where the data engineer will allocate resources like memory, and all these things, like certain amounts of data there and certain types of data. So even if you mess up that data, because remember, as data scientists, we also sort of tune the data to our liking so we can properly train the models, right? And I know now I'm starting to touch on more of the data science stuff, but just bear with me. So the data engineer provides the data scientist that sandbox environment where the data scientist can just go crazy with the data. You can tune the data however you want. You can allocate certain resources that are available on that sandbox environment. You can train machine learning models. You can build machine learning models from scratch if you want. If you're up to the challenge, So you can do all of these things in that sandbox environment, and it won't affect sort of like the overall organization or the overall data of the organization, right? And basically that's sort of like what the three do. So I'm sure from my explanation you saw that data engineers really put in the most work, but I feel like I just emphasized more on data engineering rather than just talking about the whole concept, right? Rather than just being sort of like equal on the three kind of jobs, But in my opinion, nobody does more work than the other. It really depends on the project. It really depends on the size of the data, the availability of the data, and all of that, right? And yes. Second point I'm going to touch on is choosing a career path, right? And this comes down to experience. I found that working in a data and analytics environment normally comes down to what do you enjoy doing. If you enjoy cleaning data, if you enjoy building data pipelines, hey, you're a machine learning engineer or a data engineer. If you enjoy, Power BI dashboards, Tableau dashboards, just basically visualizing the charts, the data, and all that goes into explaining a story, creating a story and giving business value, then be a data analyst. If you enjoy predictive analytics like I do, if you enjoy sort of like forecasting, like I do, then you have to do something like you have to be a data scientist basically. And that's sort of how I go about this, because normally people would ask me, what's better? Is it a data scientist or is it a data analyst? And I tell them it depends. It really depends on what you enjoy doing. So on the technical front, right, if you enjoy statistics, if you enjoy math, data scientist, you'll be fine there. As well as being a data analyst, but you don't use a lot of math there. You might use a lot of math maybe when it comes to sort of creating the formulas that sort of mold the data the way you want, but that's as far as it goes. If you want in-depth, sort of like you want to go heavily in depth with mathematics, then you have to go to being a data scientist, because that's where, machine learning models are literally maths, right? It's statistics, it's maths. So once you understand the maths of it, once you understand the foundations of statistics, then you can start building machine learning models that are very useful to business, and you can deploy them in production environments. And you can just make a lot of money with that. Yeah, because I know there's also the money issue, right? So if you enjoy cleaning data, like I said, it's definitely data engineering. If you enjoy doing these SSIS, ETLs, these SSIS packages that clean your data, take your data, loop it over something, get data from an API, put it there, and all these things. If you enjoy, like creating infrastructure that gets data from one point to another, then that's definitely your data engineering, right? And comment down below if you want recommendations on where to start with data and analytics, and I will sort of create a video on a roadmap to data and analytics. Third point, explain the differences between the careers. Now we're going on to the technical competencies, right? So technical competencies. What do you need to be a data analyst? What do you need to be a data scientist? What do you need to be a data engineer or a machine learning engineer? You don't need a lot of things, I would say, let's start with being a data analyst. You basically need knowledge of Excel. You definitely need knowledge of Power BI or Tableau or any BI reporting tool. That's where you'll be creating your dashboards, your bar charts, your pie charts, your projections and all of that. So you need something like a business intelligence tool to sort of visualize your work, your analysis, right? And you need good business acumen. I've noticed a lot of people talk about the tech stack, right? And that speaks to your technical competencies. But you also, for being a data, in fact, in any of these three, you need good business acumen. And the reason I say this is, you need to understand the business to be able to give them useful insights, right? For example, let's say I work at a ShopRite, right? And the core aim of ShopRite is to basically sell as many goods for as possible, right? Now, if I don't understand ShopRite's business model, I cannot just go and get data and say, hey, you need to decrease prices, you need to do this and that to sell more goods. No. You need to understand the business model so that you can actually provide insights that drive business value, right? So you need good business acumen to be a data analyst. You don't just need your knowledge of Excel, Power BI, SQL, and all of that. Yes, you do need those things, but those things are tools at the end of the day. And I feel like I should emphasize more on this. All these technical competencies are just tools. They don't get you paid. What gets you paid is the business value, right? If you can drive business value, then you get paid. If you can't, you're just a genius who's good at math, I guess, and good at creating dashboards, but you provide no value to the business. So why should the business pay you, So again, I digress. So again, your technical competencies, definitely Microsoft Excel. I know it's 2025, but you'd be surprised how many businesses still use Excel till this day. So you need an advanced knowledge of Excel. You need to be able to use your macros. You need to be able to use your pivot tables and understand what that is. And you need to be able to sort of use Excel sort of like the way you would SQL Workbench or SQL Server, because Excel is perfectly capable of that. It's just that it's sort of like an older kind of vintage, program, but it's still very capable. It's still very robust. And yeah, I know we're moving to cloud and moving to all these fancy tools, but a lot of businesses that I know of still use Excel. So Excel is important. You need to know SQL. So you need to know how to script in SQL. You need to know how to create tables. You need to know how to also manage your databases, like create partitions, allocate resources, and all of that. You need to be able to sort of join the data and using the right types of joins as well. So that type of thing, you need to be able to filter out the data according to certain things and certain criteria. You need to obviously learn how to sort of ingest the data in the most, resource, not resource intensive, the opposite of that. In the least resource intensive way, if that makes English sense. But yeah, and you also need, your Excel, you need SQL, you need Power BI, right? And the reason why I keep on coming back to Power BI is sort of like a standard at this point. A lot of companies prefer to use Power BI over any other BI tool. And consequently, they also use a lot of Microsoft services, right? So yeah, you need to be able to sort of get your Microsoft stack. You need to be able to use, I know that Power BI is kind of, it's not being phased out, but it's introduced under a new umbrella, Microsoft Fabric. So that's like a collection of, those BI technologies, right? So you need to be able to sort of use Power BI. You need to be an expert actually in Power BI. And that even includes using your Power Query, your DAX, and all these other ones, right? That's what you need basically to be a data analyst. To be a data engineer, you need good knowledge of data pipelines. So you need to do a course. That's my recommendation. Even though you didn't do it in school, you need to do a course that will sort of teach you these data pipelines, how data pipelines work, how ETLs work. So you need to have good knowledge of extraction, transform, and load, or extraction, load, and transform. Like ETL, ELT, you need to be very familiar with that. You need to be also familiar with data governance. You need to read up a lot on best practices for ingesting data from one source to another, or from one environment to another. You need to be very good at cleaning your data. You need to be, you basically need those types of skills, right? And like I said, comment down below if you want me to recommend courses, roadmaps, that type of thing on the next video, right? So with data engineering, you also need to be good with basically understanding data and data lakes, data warehousing, all these things, right? That's what you need. So data science, I'm gonna leave the best for last. And this is my subjective opinion. It's not the word of God. So with data science, what you need is, like I said, a good understanding, a solid maths and statistics foundation. You need to be able to use Python, and Python also goes to being a data analyst, but data analysts don't use Python as much. They mostly use Power Query and DAX. So to be a data scientist, you need to have a good Python background, because you'll be using a lot of Python libraries. Your scikit-learn for your basic ML activities. And if you wanna go into big data, then you need to know the likes of your PySpark, and Hadoop. Even though Hadoop is this bedrock, but you need to know Hadoop as well. So for your big data kind of solutions and stuff like that, you need to know like your PySpark and all of those. You need to know for your deep learning, you need to know your TensorFlow. So that's also like a Python library, and basically you just need to be very good with Python. You need to understand the mathematics behind it. You don't need to sit down with a piece of paper and start calculating and using your calculator and such. Obviously you've got programs that do that for you, but you need to understand the maths of it, because once you understand the maths of it, what happens is it's easier to sort of build the right models and to train the models on the right data, right? And again, just like with data analysis, you need to understand the business. You need to have good business acumen, right? And you also need to familiarize yourself with containerizing, with development platforms. So your IDEs like your Visual Studio, your Anaconda package manager. So basically, what you would do is you would use your Anaconda to sort of manage your different Python packages. And this is very important in a data science environment, because you find that some libraries work best with some versions of Python and some don't actually work on some versions of Python, right? But you need to have all these different versions to be able to do your job. So you can't just delete Python completely from your computer and reinstall it every time you want to use something different, right? You need something like a package manager to manage different environments or different virtual environments. And one of the best, in my opinion, is Anaconda. So Anaconda is one of the best package managers, and you need to know how it basically works and stuff like that. You need to be familiar with, this is not compulsory, but you need to be familiar with different operating systems, your Linux, your Windows, and your Mac operating systems. These big three, because business is different, right? Businesses have different needs, and basically, let's say for example, MTN's business needs would be different from ABSA's business needs, right? And the tools also that they use would be different. So you need to be well acquainted with the systems, right? You also need some coding experience. You need to be able to develop apps. Don't have to be a hardcore app developer or a software engineer, but you need to know your way around app development, what Java is, what C# is, what, those types of things. Because in most cases when you're developing your models, you need to sort of export them, containerize them, put them into an app, put them into production somewhere, and just let them work, right? And you monitor them continuously thereafter. And if you don't know how to code, you won't be able to do that, right? So you need to be able to sort of just know the code, and that's basically it. That's what you need to sort of start off on those three. Obviously, it goes way beyond what I'm saying right now. I'm just summarizing everything, but that's basically the gist of it. Yes. Now, what to do after now you've got these competencies, right? Is, in my opinion, this is the biggest one. Develop a portfolio. Now, what is it? A portfolio. A portfolio is like a tech stack, right? That's where you develop. That's where you do projects, right? You do projects and then you put them on your GitHub. You put them on a website or whatever, right? But you need to have evidence that you've done this type of work, and this are the insights, or this is the business value that it drives, right? Now, how do you develop a portfolio? Go to boot camps. There's even tutorials on YouTube. You can follow those. There's Coursera. There's LinkedIn Learning. There's this one. There's Udemy, right? There's all these platforms that basically teach you data and analytics and give you projects. Do those projects. Keep them in a portfolio. Keep them in a website. Keep them in your GitHub. Just do stuff, and that's the thing with tech. Just do. It matters more what you can do than what you have, right? So definitely develop a portfolio. And the last thing is, I want to advise you guys to start applying, right? As soon as you develop that portfolio, start applying for jobs, apply for internships, apply for graduate programs. And if I'm not mistaken, the Standard Bank graduate program is out. So you guys can also go apply there as of the making of this video. I have to put that in the thingy. So, yes, guys, and this video is in no way sponsored by Standard Bank, of course. I'm just giving you tips on, jobs that are open. Yeah, so the Standard Bank graduate program is out. I think it's the data science one and the tech one. There's also one in private banking. So do apply, do get yourself out there. Apply for as many jobs as you can. Applying for jobs is a numbers game. The more jobs you apply to, the more chances you get of being hired. So try to apply to as many jobs as you can. Do not be discouraged. Breaking out in tech, it's very hard. But once you actually get your foot in the door, you realize, oh, okay, there's a lot of opportunity for growth and for development in your career. And again, to put it bluntly, there's a lot of money in tech. And that's just how it is, But you only get the money. You only get the money. You only get the money if you apply yourself, right? If you upskill yourself, if you work on projects, and if you develop, that portfolio, right? If you actually get your name out there as someone who gets things done, then there's a lot of money to be had. There's a lot of progression to be had, And yeah, that will wrap up this video, guys. Thank you guys for your time. Thank you for listening. Thank you for watching. And if you find this information valuable, please like, share, subscribe, all that stuff, And I'll see you on the next one.